Okay, this is going to be the second part of simple and compound probability. Yesterday we went over all this, which had all the stuff on the decks of cards and whatnot. Today we're going to be showing you probability trees and probability tables and how that works. Probability trees are great when you have multiple independent events occurring. So maybe like you have three things going on at the same time or two things going on at the same time. And it allows us to be able to kind of map and see what branches, through doing different branches, what they look like. Okay, so what do I mean by that? Well, on probability trees, you're always going to start with a dot on the left hand side. So we're going to start with the dot right here, and these things are going to branch out. So you want to make those dots kind of towards the middle if you can. Okay, so the middle on the left hand side, right around there. We're going to be flipping two coins on that first example and see what that leads up to. So on the first coin flip, there are exactly two things that can happen. I can either get a heads or I can get a tails. So from that dot, I'm going to go ahead and branch out with two different branches, one going up, one going down. And one of the options that can happen is I can get a heads, or the other thing that can happen is I can get a tails. And I'm going to go ahead and highlight that as my first event. Now, that takes care of the first coin, but let's say on the first coin, I'm actually over here and I got a heads, okay? Then there's another event that's gonna happen. I'm gonna flip the second coin, and when I flip the second coin, even though I got a heads on the first try, it doesn't matter. On the second coin, I still have two different options. I can get a heads or I can get a tails. So if the first coin is a heads, then the second coin can branch out into two different things, and it can either be a heads or it can be a tails. I'm going to go ahead and highlight that in green so that way you can see like this is the second coin over here. Now that's assuming that the first coin was a heads, right, over here. But it didn't have to be a heads, it could have been a tails. If the first coin was a tails, then I still have to flip the second coin. And remember, you're going to get two different options. So from there, I'm going to branch out two different times. And this thing is either going to be, the second coin is either going to be a heads or a tails. So we've come up with all the possible combinations on flipping two coins. And it's really important that we're able to backtrack our way to see exactly what it is. So for example, in order for me to get here, we're going to count up that there's four different possibilities. So 1, 2, 3, 4. Let's highlight about this one right here. If I ended up here, that's because if I backtrack, that means I took this route, right? And in doing so, that means my first coin was a heads and the second coin was a heads. So this is modeling a heads and a heads. If I look at this route, then to get here, I must have gone this way, which means on my first coin, I got a heads, and on the second coin, I got a tails. If I look at this route, then that means I must have gone this way, which means on my first coin, I got a tails, and on my second coin, I got a heads. And lastly, if I came through this route, that means I must have gone through here, which means I got a tails on the first coin and a tails on the second. So these are all the possible combinations. If I were to ask you what's the probability, well, first of all, notice that there are four total outcomes. If I were to ask you what was the probability that the coins match, it would be 2 out of 4 because here's two coins matching and here's two coins matching. That would be 2 out of 4. If I asked you what's the probability of the two coins not matching, that would also be 2 out of 4 because you could either get a heads and a tails or a tails and a heads. Okay, and I think this one's the one that's the hardest. If I were to ask you what's the probability that you get at least one heads, the probability they get at least one heads, well, this one has at least one heads. This one has at least one heads. This one has at least one heads. This one does not have at least one head. So in this case, the probability of getting at least one heads would be 3 out of 4. That first one, you got two heads, which is great. That's at least one. Okay. So that's an example of a probability tree. Let's show you one more example, and hopefully it'll make sense. If you were to play rock, paper, scissors with a friend, let's go ahead and show all the combinations. Now, we did that on, I believe, on Friday, but I want you to take another look at it here. If I were to play rock, paper, scissors, then player one would have exactly three options. Remember, our probability trees always start with the dot. So I'm going to go ahead and put a dot here. And the options that player 1 has is he has 3 options. He can either get a rock, or he can get paper, or he can get scissors. So because they had 3 options, I'm going to go, whoop, sorry, I didn't mean to put a 3. I meant to put an S. Since there are 3 options, then I drew 3 branches. So the first player either picked rock, paper, or scissors. Now, let's pretend that the first player picked rock. Then we still got to worry about the second player, and how many options do they have? Well, they have 3. They can either pick rock, paper, or scissors. That means from each one of these letters, I need to branch out 3 different times. So on this one, I'm going to say the second player could have picked rock, or they could have picked paper, or they could have picked scissors. And that would give you all the options here. But maybe the first player did not pick rock, and maybe they went with paper. Well, from the paper here, now we got to get player 2 to try their hand at their stuff. So again, player 2 is again going to have 3 options. They can either pick rock, or they can pick paper, or they can pick scissors. And then lastly, if they would have picked scissors, then if player 1 would have picked scissors, then again we have 3 options for player 2. They could have picked rock, they could have picked paper, they could have picked scissors. So if we were to count up all the different combinations, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 combinations, which is exactly what we came up with last time. Understand what this combination in particular does. Again, if I were to backtrack, it would be this route. That means player 1 picked rock and player 2 picked scissors. Okay, that's how we would read this. There are 3 different ways to tie. That would be with a rock and rock. That would be with paper, paper, and with scissors, scissors. So the probability of tying would be 3 out of 9. And then let's do a tough one. What's the probability of at least 1 rock? So I'm going to look through, and I notice that this one has 2 rocks. So that one counts. Check. So that's 1. This one also counts because I see a rock right there. This one also counts because I see a rock right there. So far, this one, and this one all work. This one, that one works too because I see a rock for player 2. This one does not work. There is no rock. I only see is paper, paper. And this one does not work either because there is no rock. I see paper and scissors. So far, this one, this one, this one, and these ones, so 1, 2, 3, 4 are the only ones that work. The only other one that works is this one over here because I see a rock for player 2. Unfortunately for the other ones, there's no rock over there and there's no rock over there. So I believe we counted up 5. 1, 2, 3, 4, 5. Those all have at least 1 rock. And you would say it's 5 out of 9. So the probability that somebody put down a rock while you guys are playing is actually more than half the time. Okay, let's go. So that's one way you can show your probabilities is by doing probability trees. We can also set up probability tables. Probability tables are really good if you are only having 2 events. So for example, if there was another piece to this puzzle, I could continue adding over here. Like let's say, and then at the very end, you flipped a coin for some reason. You can continue adding different events. You don't have to stop at just 2 events. Probability tables are great if you're going to be only doing 2 events. So let's see. Let's find the probability that I roll a pair of dice and find the sum. Remember, a die looks like this. A pair of dice is basically 2 of those, and the options that you get are 1, 2, 3, 4, 5, and 6. So I'm going to go ahead and write the notes for this. I'm going to make a table. On this first table, we're going to go ahead and make a really, really thick line going this way. And this is going to represent all of the options for the first die. So on the first die, let's pretend I have a green die and a pink die, okay? On the first die, which we're going to call the green die, On the green die, I can either roll a 1, a 2, a 3, a 4, a 5, or a 6. So let's leave that first spot blank right here. And from there, I'm gonna say that on the green die, I can roll a 1, I can roll a 2, I can roll a 3, I can roll a 4, I can roll a 5, I can roll a 6. These are the possible things that I can roll with my green die. If you have highlighters, I highly suggest that you highlight that top part only. So that's what can happen on my first die. I can roll a 1, 2, 3, 4, 5, and 6. On my pink die, it's the exact same thing. I can roll a 1, I can roll a 2, I can roll a 3, a 4, a 5, or a 6. These are the things that can happen on my pink die. Now, some of you guys inevitably are going to start noticing, like, oh, it looks kind of like a times tables chart. And yes, except we're not going to be adding. I'm sorry, we're not going to be multiplying. We're going to be adding, okay? Because when you roll, when you play with dice, whoops, I don't know what happened there. Sorry. When you play with dice, you don't multiply the two numbers together on your dice. You add them. Okay, so these are all the numbers that I could have rolled on the pink die. Now, it's very, very important that you understand what it is that we just did. These are all the things that can happen on my green die. These are all the things that can happen on my pink die. Let's say I roll them together, and what I end up is this box right here. What does this box represent? This box represents that I rolled a 5 on the green die, and I rolled a 3 on the pink die. If I roll a 5 and a 3, then you add them up together, and that means that here I actually ended up rolling an 8 total because 5 plus 3 is 8. On this one, this represents that I rolled a 2 on the green die and I rolled a 1 on the pink die. And if I rolled a 2 and a 1, then that means in this box I should represent that I rolled a 3. So you go. What I need you to do is I want you to press pause on the video, and I want you to go ahead and fill out the rest of the table. Do so right now. Press pause. I'm gonna just pretend that you already did that, and I'm gonna go ahead and start filling out the table myself. But it's really, really beneficial if you do it on your own, so that way you can kind of start recognizing your own patterns. So let me go ahead and get started with this, just in the interest of time. So let's see. This is 2, 3, 4, 5, 6, and 7, and then 3, 4, 5, 6, 7, 8. A lot of patterns that hopefully you start seeing are developing. Okay. So I didn't ask this earlier, but that's okay. If you look and I said, hey, you roll a pair of dice, what is the hardest numbers to get? Well, it is very, very difficult to get a 2 because there's only one way of getting a 2. The only way you can get a 2 is if you roll a 1 and a 1. There is only one way of rolling a 2. The other hard number to get is a 12. It is very, very difficult to get a 12. The only way you can roll a 12 is if you get a 6 and a 6. The easiest number to roll is a 7 because there's many ways of getting a 7. You can get a 7 like this, or this. Look at all those ways of getting a 7. You can roll a 7 with a 6 and a 1, or you can roll a 7 with a 5 and a 2. You can roll a 7 with a 4 and a 3. You can roll a 7 with a 3 and a 4. That's different than the 4 and the 3 because of where the 4 is coming from. On this one, the 4 is coming from the green die. On this one, the 4 is going to come from the pink die. Okay. And you can also get a 7 with a 2 and a 5 and a 1 and a 6. The other thing I want you to notice is how many different combinations are there. All the combinations are right here. I'm sorry, all the different outcomes. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I'm not going to do that. You could count them all up and get 36. A faster way of saying is this is a 6 by a 6. 6 times 6, you get 36 different outcomes. Okay. Okay. So let's start finding the probabilities. Probability that I roll a 1 when I rolled both dice. Well, look at your outcomes. I don't see any 1s over there, so this is 0. It's impossible to roll a 1 if you're rolling 2 pairs of dice. What's the probability you roll a 2? Well, there's only one way of rolling a 2. So I'm going to say there's only one way out of 36 to get a 2. How many 3s are there? Well, there's 2 3s. There's 2 ways of getting a 3. 2 out of 36. You can either roll a 3 with a 2 and a 1, or you can roll it with a 1 and a 2. The probability of rolling a 4 is 3 out of 36, and I'm going to go ahead and just start filling out the rest. 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, and you would think it's 7 out of 36, but it's not. Because with the 8s, there are only 5 8s. So this is 5 out of 36. And with the 9s, there's only 4 9s. 4 out of 36. 3 out of 36. And this is where I realize my mistake, where I go, whoops, I forgot to write the number 11. That was not done on purpose. That was 100% on accident. So if I'm making you use your eraser right now, I am super sorry for that. And let me just go ahead and delete this. Forget this. That's too much work, not enough payoff. So probability of getting an 11, probability of getting a 12. Probability of getting an 11 would be 2 out of 36. And it looks like I lost that 3. The probability of getting a 12 is 1 out of 36. Okay, so, and I mentioned this in class. We said that the easiest number to get was a 7. Guys, that doesn't mean 7 is a lucky number. It just means mathematically 7 is the easiest to roll because there's so many ways of getting that 7. So hopefully, if you ever hear like people say 7 is my lucky number, now you know where that expression is coming from. It just happens a lot because math. Yeah. All right. And this is going to be our last example. I'm going to be doing another experiment, but this time I'm going to spin this spinner over here, and then I'm going to roll a die. So because there's only 2 things happening, I'm spinning and I'm rolling. I'm going to go ahead and use a probability table again. So let's see. I'm going to go ahead and draw my really, really dark line right here. And I'm going to go ahead and label that this is coming from my spinner. Well, I'm going to hold off on the spinner for right now. And then the other side, I'm going to say that this is coming from my die. All right, so the die is definitely really easy. What could happen on my die? Well, on the die, I can roll a 1, a 2, a 3, a 4, a 5, or a 6. I'm going to go ahead and write that down right now. I can roll a 1, a 2, a 3, a 4, a 5, or a 6. And since it's coming from my die, I'm going to pretend it's a pink die, and I'm just going to go ahead and color that pink. So here's the things that can happen from my pink die. I can go roll a 1, 2, 3, 4, 5, and 6. The spinner is a little bit controversial because if I look at that spinner, I'm gonna ask you how many different things can happen on this spinner, and I'm gonna get some answers of 3, and I'm gonna get some answers of 4. So let me go ahead and just start at this top part, and let's just talk about what that means. I can land here, 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 or here, but the question becomes, should I write this one twice? Because I see 2 of them. Well, let's try to draw it, and let's just see what it would look like. If I were to put it on a table, that means that this would be pink, green, and yellow. That's one option. But does that really represent what your spinner looks like? Or do you think we need like that extra green piece? And that's more like what your spinner looks like. And guys, I know it's twice as many greens as there are yellows, so we need to include that here. Now, if you don't like that, right, because I know that that's kind of hard to see and you're going like, wait, what? Why are we writing that green twice if it's the exact same color as the other green? Well, because and let me go ahead and start drawing it like this. I think it would make a lot more sense if instead of calling it green and green, I'm going to call this one green 1 and I'm going to call this one green 2. And that makes it a little bit easier to think because if I say, hey, I landed on the pink spot, you're going to know, oh, you mean I landed here. But if I would have said like, hey, I landed on the green spot, you would not have known if it's this one or this one. However, if I said if I landed on the second green spot, you're going to know because it has that G2, like, oh, you mean I landed here. And if I said, no, I landed on the first green spot, then you're going to know, oh, then for sure I landed here. And that is different from landing here. Like, I understand they're both green, but it's a different spot in your spinner, okay? So that's exactly the way we're going to write this. We're going to say that this is, I can either land on the pink spot, I can land on the green first spot, I can land on the yellow spot, or I can land on the second green spot. So I'm going to call them G1s and G2s, okay? And on this one, I'm going to go ahead and just highlight this just so I know it's a different event. Not that all of those things are green, just more like this is the other thing that's going on. All right. Now, on the last one, we added them up, but it doesn't make sense to add up a pink with a 4. Like what's pink plus 4? That doesn't, I don't know. So instead of actually adding them, we're just going to put them together. Like we're just going to write them as a combination. Like I spun a pink and I landed on a 4. That would be this spot right here. I spun a pink and I landed on a 4. What are we going to call it? We're going to call it P4. And you'll know I landed on a pink and I rolled a 4. That means this one. What would we call this one? Well, that means I spun a yellow and I rolled a 2. So I'm going to call it Y2. The weird one is going to be this one. How am I going to call this one? Well, I landed on the first green spot and I rolled a 3. So I'm going to call it G13. Go ahead and press pause in the video and fill out the rest of it. I'm going to go ahead and have this completely filled out. So press pause on the video unless you want to just see what it should look like. And I'm back, and this is the way your table should look like, okay? Now that we have our table filled out, let's go ahead and start writing some of these probabilities. I want the probability that I end up with a pink, and it's a 5. So I'm going to look at my outcomes over here. First things first, I need to figure out how many different outcomes were there total. Again, you can count them all up. I'm not going to do that. Instead, I know that there are 4 spaces going this way, 6 spaces going this way. 4 times 6 means that there are 24 outcomes total. I'm going to go ahead and write this here because I know all my denominators now are going to be out of 24. Okay, I want the probability that it's pink and it's a 5. It's got to be pink and it's got to be a 5. Well, these are pink, but that is not a 5. And these are 5s, but that is not pink. So the only one that's a pink and a 5 would be this one. It's P5. And there's only one of those P5s, so this is going to be 1 out of 24. Okay, next one. I want to know the probability that it's pink. Okay, well, let's look at all the pink ones. I see P1 is pink, P2 is pink, P3, P4, P5, P6. These are all pinks. I don't see any more pinks across my board, so there's 6 of those pink spots. That's 6 out of 24, which will simplify to 1 out of 4. On this one, they're using the word and, which means I need to make sure that both are happening. It needs to be green and it needs to be a 3. It's got to be green and it's got to be a 3. So let's see. I see all of these greens, but not all of them are 3s. So the only green and 3 that I see is this one right here. So that means I landed on this first green spot and I rolled a 3. But I could have also landed on this green spot and rolled a 3, and that would be G23. So this is green and 3. This is green and 3. These are the only 2 that are green and 3. So I'm going to write this as 2 out of 24, which ends up being 1 out of 12. All right, I want the probability that it's yellow and it's an odd number. The ones that are yellows are here, but not all of them are odd. The yellow odd ones are this one, the Y1, Y3, and Y5. They're yellow and they're odd, so this is going to be 3 out of 24, which ends up being 1/8. Next one is the probability that it's pink and it needs to be less than 5. So here are my pink ones, but I only want the ones that are less than 5. So that means I don't want that one and I don't want that one. But these are the ones that are less than 5. That means I have 4 of those things. This is going to be 4 out of 24, which ends up being 1 out of 6. The probability that it's green, oh man, there's a ton of green ones. Look at all these green ones here, and look at all these green ones here. If I add those up, that's 12 total. 12 out of 24, which ends up being half of them. are green. And then the last one, probability that I get a 2. It has to have a 2. So I know the pink and a 2, green 1 and a 2, yellow and a 2, green 2 and a 2. That would be 4 out of 24, which simplifies to 1 out of 6. Okay, those are all the notes we have for today. As always, if you have any questions, please feel free to ask.